Today, we're going to solve a common household puzzle, the mystery of rusty water. We're going to pull back the curtain on the hidden science that's happening inside your pipes and at the treatment plant, all to keep your water crystal clear.
You know that feeling, right? You go to fill up a glass of water, maybe start a load of laundry, and bam, the water comes out with this weird yellow, red, or even brown tint. Well, if that's ever happened to you, you're not alone. It's an incredibly common thing, and today we're going to figure out exactly what's going on.
So let's just dive right into it and define why this is such a common and, let's be honest, frustrating problem.
Yeah, it's not just about how it looks. This stuff has real consequences. I mean, it can permanently stain a brand new white shirt, leave these awful discolorations on your sinks and tubs, and it gives the water this funky metallic taste. And believe it or not, it can even lead to some pretty gross, slimy stuff building up inside your plumbing. Okay, so who are the main culprits behind this whole mystery? Let's meet our two troublemakers, iron and manganese. These are totally natural elements, and you find them all over the place, especially in groundwater that comes from wells. Now, here's the first question on everybody's mind. Is this stuff dangerous? And the good news is, no. Iron and manganese are actually essential nutrients our bodies need. So the problem isn't a health hazard. It's what's known as an aesthetic issue. Basically, they just make the water unpleasant, and they do it at surprisingly low concentrations. But wait, there's a little twist. These elements are also the favorite food for a specific type of bacteria. Yeah, they're called iron bacteria, and they just munch away on the iron and manganese, and as they do, they create this thick, rust-colored or black slime that coats the inside of pipes. So when that slime breaks loose, you get a sudden, nasty burst of dirty water. So how much does it actually take to cause a problem? Well, for iron, the standard for it to be an aesthetic issue is just 0.3 parts per million. To put that in perspective, that's like a few drops in a massive swimming pool. It's a tiny, tiny amount, but it is more than enough to start causing stains. And get this, for manganese, it's even less. The standard is just 0.05 parts per million. That's because manganese is a way more powerful staining agent, which is why that limit is a full 6 times stricter than it is for iron.
All right, so if we know what the culprits are, why can't we just filter them out? Well, that brings us to the real scientific challenge here, what I like to call the invisibility problem.
You see, deep in the ground, where there's no oxygen from the air, iron and manganese are completely dissolved into the water. They're so small they would sail right through a normal filter, kind of like how sugar disappears when you dissolve it in your coffee. The water can look perfectly clear, but the problem is still in there, just lurking. So if you can't filter out something you can't even see, the goal for water treatment becomes really, really simple, at least in concept. You've got to make the invisible visible. You have to force those dissolved little particles to become solid ones. And the scientific trick to do that is a process called oxidation. You've definitely seen this in real life. It's the exact same reaction that makes a piece of iron get all rusty when you leave it out in the rain. So by adding an oxidizing agent, we can trigger a chemical reaction that turns that dissolved invisible iron and manganese into solid, visible particles that we can finally grab. Now, there are a couple of ways to tackle this. The first one isn't really about removing the problem at all. It's more about masking it. Think of it like putting the troublemakers in chemical handcuffs so they can't cause any problems. This process is called sequestration. What happens is special chemicals called polyphosphates are added to the water. They basically hunt down the dissolved iron and manganese ions and wrap around them, creating a sort of chemical shield. And that shield stops them from reacting with oxygen and turning into that stain-causing rust. But sequestration definitely has its limits. It really only works for very low levels of iron. And remember, it's not actually removing anything. It's a temporary fix. If the water sits around in the pipes for too long, say more than 3 days, that chemical shield can actually break down and boom, the iron is free to cause problems all over again. So for higher concentrations, which is what most cities and towns are dealing with, you need a much tougher solution. You need to actually get the iron and manganese completely out of the water. And this brings us to what I call the oxidation showdown. This right here is the gold standard for treatment plants. It's a classic 1-2 punch. First, you oxidize the minerals to make them solid, and second, you filter those solid particles right out. It's simple, it's effective, and it's a permanent solution.
Water treatment plants have a few different tools in their toolbox for this oxidation step. They can use simple aeration, which is really just mixing water with air. It's cheap, but it's also slow and doesn't work so well on manganese. Or they can use chlorine, which is super fast and powerful, but has its own set of complications. And then there's potassium permanganate, which is an absolute champion at oxidizing manganese, but you have to be really careful with it or you can accidentally turn the water pink.
Okay, once the oxidation showdown is over and we have a winner, we are ready for the final and most crucial step in the whole process, getting those solid particles out of the water for good.
And this is the magic of oxidation. We've successfully turned our invisible dissolved minerals into visible, solid particles. They're not technically part of the water anymore. They're just floating around in it, ready to be physically snatched out.
Here's a look at how that actually works. Water flows in from the left, and a chemical like permanganate gets injected to kick off the oxidation. Then that water goes into a big tank filled with a special filter material, often called greensand. This stuff is specifically designed to trap all those tiny rust and manganese particles, letting only the clean water flow out the other side.
And here's a bigger picture look at a larger system. This maps out the entire journey. You have the raw water coming in, chemicals are added in a mixing tank, then it moves to a sedimentation tank where the heavy oxidized particles get a chance to settle to the bottom. For that final polish, it flows through a filter to catch anything that's left before it's finally sent out to your home. And the result of all of this chemistry and all this engineering is exactly what we all expect when we turn on the faucet. Perfectly clear, clean water with no stains and no metallic tastes. So the next time you pour yourself a glass of water, just take a second. What looks like simple, beautiful clarity is actually the end result of a pretty fascinating scientific journey. A whole process designed to catch invisible troublemakers, all to make sure that what arrives at your tap is nothing but pure, clean water.